What is up, party people? All right, gonna be a good one. Just wanted to say, I just want to say thanks to basically, all you guys, because realistically, I'd be talking to myself if it wasn't for you guys, and also the people that jump on the panel. I appreciate the shit out of that. I guess today's just a really good day. I don't know, in good mood. I don't know why. But with that said, let's see if we can get myself into a bad mood and talk to some flat earthers. Obviously, I've really stuck to my guns on the topic of gravity and different things that we do understand about it and versus the stuff we don't. And with that, I've gotten a lot of input, from globers, flat earthers. But one of the things that I feel is still a serious issue with this community. When I say community, I mean flat earth and globe. Is still this confidence thing. Flat earth, they think they got it figured out with zero evidence. And that's normal now. I mean, anyone who's shocked by that, I don't know where you've been. But what I feel is worse is that confidence that a lot of globers run around with. Confidence that they understand what's going on more than science does. It's kind of confusing. It's frustrating for me because I'm someone who's learning, and not only am I trying to pick up on these things, but I'm also having to dodge and weave these people that have or as I call it, more confidence in science than science has in itself. That is actually the reason that I actually started really thinking, could it be flat? When I became a flat earther. Just the pure fact that, people just talk out their ass and don't really know what they're talking about. For instance, yesterday it happened with Rumpus, or actually a couple times it happened with Rumpus. Rumpus likes to get everything he has to say out in a half a second, and if he doesn't, he gets frustrated. Problem with what he does is he speaks faster than his brain works, or his brain works faster than he speaks. Either way, he puts himself in these situations where flat earthers just jab at him because he does this. He did it yesterday when it comes to dark matter. When it came to me asking him how they know the mass, or he was trying to explain to me that we know the amount of mass of dark matter we have in the universe. They can't see this dark matter. Yesterday I had said it pretty clearly. There's no real reason at all to pretend as if we know everything, because science doesn't. They don't even do it. So when someone like Rumpus comes around and says they know exactly how much matter, mass, whatever, is in the universe, it's not true. For one, it's in our known universe. For two, gravitational lensing does not tell you the mass. It can help you It tells you the size, and when Rumpus shows up, I'll explain this to him as well, because since yesterday, today, all I've done is look up this how we know the mass. We don't. We know that the areas inside our galaxy that do have this dark matter, we know it takes up this amount of space. And if for ones that don't know, it's, what's the number I'm thinking of? It's on top of my head. Let me just go pop to it so that way I don't have to guess. But it's pretty simple. This one. Okay, so as we understand it, when I say we, I mean science. And again, this is very important. They are not telling us the exact amount of matter. They can't. They can't even see it, Rumpus. And this is their calculations. They believe, or let me read it as they do so you can understand where he leaves off when he's talking about this stuff. Because remember, they know is what he said. Dark matter is a form of matter, though to account, or thought to account for approximately 85% of the matter in the universe, and about a quarter of its total energy density. The majority of dark matter is thought to be a binary in nature, possibly being composed of some as yet undiscovered subatomic particles. Again, never said he knew that he claimed we knew the particles. We don't. But again, you don't know particles. You don't know the dynamic structure of it. How do you find out the mass of it? There are a couple ways that they try, or they can approximate these things. For instance, gravitational lensing tells them it's there. It tells them how big that object that crossed the star is compared in relation to what we've observed from here with other planets. Understand, that's not always correct. Or sometimes they don't even know what the hell they're looking at. I think it was probably about 4 months ago, maybe. I showed a video from TED Talks. And there was a lady on there that was an astronomer. She was talking about a couple findings they had. I think it was about 6 years ago, about 6 years ago, about now. They were doing what they do. They were looking into the galaxy, or into the universe, and they saw what they believe to be something. All right. Let me know if you guys can hear me in the chat. I just want to make sure everything looks good. Again, I had to deal with the dogs kicking it out, so I apologize for that. Go ahead and refresh, and it'll probably fix it for you guys. You'll guys be all good to go. All right, let me see here. Hopefully it is working. Let me know in the chat that you guys can hear me and everything's good to go. Let's see. All right, cool. Perfect. So let me get in this chat and say what's up to you guys. What's up, Ted? How you doing, sir? What's up, B-Ball? My friend, how you doing? Again, guys, I'll put the link. Actually, I gotta put the link in there right now. We'll figure this out. All right. What's up, Riz? What's up, Ali? How you doing, sir? What's up, Jackie's 9? What's up, Seek and Find? Who else is here? What up, Night Demon? Blue Marble. How you doing, sir? Yeah. Okay. Make sure you guys like it, share. Make sure everyone gets to know, especially because of what just happened. Pretty sure everyone's like, oh, I guess he's cutting off. But no, I'm here. Yeah, the freaking dog fucking kicked it over. It shouldn't be buffering right now though. If it is, just lower the resolution. I think I'm only at 720, so it shouldn't be that bad. Let me see here. We'll get the link out there to get this over with and do this now. One more thing I gotta do, switch my speaker. So I will be able to hear you guys. All right, so get this link out there. Actually, I probably should rejoin the call, huh? All right, there you go. All right, so I'm gonna join here. Turn this back on. And like I said, we're gonna kind of just jump around topics. You guys know me. Topics usually change right away anyway. So let's see. All right, there we go. Good, get the link out there. Thank you, Night Demon. I appreciate that. You guys in here. Again, there's a few things I want to talk about off topic stuff, and we're gonna jump around a lot today. Again, one of the things I wanted to talk about is this overconfidence that a lot of people have when it comes down to it. Ooh, I need to go. Let me do this. I gotta do that. I'm gonna remove that. That was your guys' opportunity. Oh shit. Hey Alan, rejoin. I messed up. My bad. Rejoin, please. That was a complete accident. Oh shit. Let me see. I gotta get to Discord. See if I can get Alan back in here. Alan, if you hear me, come back in. Hopefully you'll be able to. I messed up. And let's see here. Okay. Let me get that link out to Alan. I fucked up and kicked him. Didn't even mean to, so. Where are you? Looking for you at the moment, Alan. I do apologize. Let's see, where is Alan? If you guys want a link, let me know, and I'll get that link out there to you guys. But at the moment, I'm trying to find everyone that I can give this link back to. Definitely try to get Alan back in here because I feel bad. That just happened. Yeah, so the link is in the bunker, just so you guys know. Let's see. God damn it. There we go. Cool. Yeah, it's in the bunker, and then hopefully Alan can hear me because damn, I feel bad for that shit. Let's see what we can do. I don't know who you are. I'll make you excited for now. All right, let's make sure I don't do that again. What's up, Alan? I apologize.
That's all right. Easy enough to hit the wrong button, isn't it?
Yeah, I was like jumping around between screens, and I thought I was going to be able to do it quick style, and I messed up. Sorry.
Don't worry.
Yeah.
Not like it's not the sort of mistake I'd make.
Well, because I'm not 100% comfortable with this the meets yet. And remember, if I would have done that on the Hangouts, you wouldn't have been able to come back in. I would have had to start a new Hangout. So I was kind of worried about that. I was like, oh man, I hope I didn't really mess that up. How you doing, Blue?
Hey, what's up, Shawn G?
Just hanging out, just relaxing on this wonderful day.
Yeah.
Yep. You were here for the Rumpus. No, you came a little late for the Rumpus thing. Alan, were you here for Rumpus yesterday?
No, I missed it. I was a bit. I had a bit of a busy day because I was helping Terry Davis, the Aussie guy, do his stream during the day. So by the time it got around to the evening, it was like, I've had enough now.
Yeah. Yeah. I was going to stop by over there. I got to tell him if he needs any help, let me know. But let me see here. Because,
we're getting there.
I figured out, I have OBS figured out pretty much. But what I'm going to do is I got like 5 how-to for the OBS and YouTube video uploads I have. I just have to upload them still. But it's harder to remember what people have issues with. So what I'm probably going to do is have people just start emailing me their list of things they need to know for it, and that way I can start running tutorials off of that.
Yeah, I mean, I've pretty much got OBS figured out.
Mm-hmm.
The one I'm now having fun with is Potato.
Potato, what's that?
Voice meter, Potato.
Oh yeah.
The
Is that like the voice banana or something like that?
yeah, they
Yeah.
do banana. They do banana and potato, and it's like I
Yeah.
just looked at. I just thought, well, I'll just learn Potato because Potato's the one that's got everything in it, and but because they do voice meter banana, and voice meter potato, and basically you just get more bits in it.
Mm.
Well, I figured if I learn Potato, that's great because you get 5 hardware inputs and 3 virtual inputs that you can then pipe through. So I know you don't necessarily need 5 hardware inputs, but the 3 virtual inputs can be handy because then you've got yeah, you can have it coming from Meets, YouTube, and somewhere else if necessary.
Yeah.
Because you can also put in a virtual sound desk as well.
Yeah, well, like
So you can,
you know how like with the Hangouts, if I share a video right now, you guys can't hear it.
yeah,
With that, you guys would be able to hear it. That's why I tried voice banana. It was like it'd work perfectly. Then I'd get to the stream and wouldn't work at all. I probably spent 15 minutes one day trying to figure the audio out because of it.
yeah.
It was pretty bad.
So yeah, that's why I figured if I worked with the full one to start with, the simpler ones should just be easy because from looking at the interface, they work just the same. They just have less inputs and outputs.
Mm.
So
You would think it's 2019. You would think they would have like computers that come with like all these different type of sound cards and modulators that are able to do these things. You shouldn't have to go out and spend so much damn money.
well, I guess it depends. See, the thing is that you can now set your computer up to do this, whereas 10 years ago you'd have needed a couple of $1,000s worth of hardware.
Oh yeah. and
So,
no more than that,
so
because you would have wanted to get the best internet, and back then it was dial-up still, or not 10 years ago, a little bit further, but yeah, it was pretty much dial-up
yeah,
still.
I was just talking about getting the audio.
well, that'd have been the easy part back then.
Yeah, but yeah, you'd have still needed, several $1,000s worth of audio mixing desk, hardware mixing desk to mix the audio to put in for
Oh
your,
yeah.
it's like, yeah, and considering what you get with voice meter for about $25 because it's donationware. I think that's actually a pretty good deal.
Yeah. Oh, well, 1 second. All right, wait. Thanks, you B-ball, man. Thank you. I really appreciate that, man. No need for that, though. Let me see here. I know there was one more. Night Demon. Thank you again, my friend. Appreciate that. Let's see. Yeah, it's weird. I didn't realize, because a lot of people don't realize it. When you use OBS, you're using the same thing a news broadcast uses. Well, scaled down a little bit, but it's a really good building block to learn how the production part of the side of things go.
Yeah.
One of the things that I've now started to look into and I'm preparing for is networking. I'd like to do that. I'd like to, start a network like for multiple people who want to start sharing content, but don't want to build the channel up or whatnot. But whatever reason there may be, some people rather just focus on just having the stream, not what's going on behind the scenes. So
Yes.
I want to get used. I want to get myself adequated with that and figure out a lot of other things, and then hopefully in the next 6-7 months, 8 months, start kind of backing off the streaming and start networking, because I actually enjoy the setup and the production part of it. Believe it or not, people, I'm not a talker. I know you don't believe it, but trust me, I don't run around just talking to everybody. It's not how I roll. I guess I must like you guys, kind of.
I have noticed there are some days when you basically shut up and say nothing, and other days when you will have a long conversation with people.
Yep. Well, see, like, because there are those days where, like, I'm just not in the mood, or like I get tired early or something like that. Again, like I thank you guys a lot for this. There are those times when that happens. If I have a panel, you guys kind of just take over, and it really helps me out, because there are days where, like, I'm running around the house, or my son's here and I gotta help him with his homework, or like I get to do a lot of things because of you guys. So I appreciate the crap out of it, man. And just I get to listen and learn. That's the main reason I do this. Get smart people like you guys on the panel. You guys start talking and explaining things, and sometimes things click, and I understand that, or sometimes I get a better idea for this, and just the brainstorming is the main reason I'm here. That's it. Go ahead.
Because it's only 11:30 in the morning for you, isn't it?
Yes.
Yeah. Because it's 7:30 in the evening here.
Yeah. Well, but in Australia, I think it's like what, almost midnight-ish, something like that. A little bit.
No, it's
a little bit earlier.
No, it's about 5 o'clock in the morning on the.
All right. Hopefully this works again. Jesus Christ. I am so sick of OBS. Let's see if I can get back in the call. All right, cool. Damn. Sorry about that, guys. This shit is irritating the crap out of me. I gotta relocate that cord.
Man, you should learn the miles, man.
All right. Sorry, guys. I cut out again.
We're not American.
You're not American?
No, we're not all American. I'm not
what
American.
Are you?
I'm English.
My bad. What are you? Oh, you're from England.
English.
Okay.
All right. Hopefully that will be the last time that happens. Fuck. It's getting ridiculous.
That a lot of these people are like military, man. Like, including the flat Earth and Globe Earth believers. A lot of them are ex-military. I'm just saying.
Well, there's an awful lot of ex-military. If you think about it, there's an awful lot of ex-military people out there. Some countries still have conscription. So, of course, people who live in those countries will have served because of conscription.
Yeah.
The US.
You don't think there's a conspiracy going on? Like, maybe perhaps there's a psyop going on?
No.
Wait,
no.
Because I know
of what?
Because I know how incompetent the armed forces of both the United Kingdom and the United States are.
It wouldn't be the military.
Okay.
Well, Manny, you got to remember, it wouldn't be the military.
I like that.
It wouldn't be
the military.
Manny. It wouldn't be the military.
What's up, Sean?
It wouldn't be the military, like the actual soldiers. It's gonna be the guys in the background, like lawyers or dignitary, like legislation. It's gonna be higher ups. Military is like foot soldiers. They're not doing anything.
Yeah, I got it.
One of those type of things
are pawns, right?
No. Yeah, in a way. But you got to remember this. So, do you know anyone that serves in the military?
I'm sorry?
Do you know anyone personally that serves in the military?
That serves currently, or who has served?
It has served. Either way.
Both. Yes.
Okay.
Both. Yes.
Do you think that they would put you and your family into an internment camp?
No.
Exactly. They're not going to do it.
Not them per se, but
you need to worry.
Perhaps it can be. They can be. What I'm saying is, I'm not really trying to talk about like conspiracies, but I was talking about the radius. But go ahead.
I don't know, but it all kind of goes
kinda
into itself.
digressing. It's all good, though.
It's the idea that they're lying. Is it feasible to lie about what? That's kind of where I'm going at it too. So it full circles back, but the idea that they're lying about the shape of the Earth, it's kind of far-fetched because I can go outside right now and make multiple observations that show they're not lying.
Really?
Mm-hmm.
Which one would you say is a good one?
Sunrise, sunset.
Yeah.
Oh, but you know what? So, but flat earthers would say or argue with that, saying that it's perspective, it's vanishing point.
Okay, well then you would have to explain how that is, because I can explain exactly how it rises and sets and why we can predict.
Well, there has been plenty of them, but it's a matter of whether you accept it or not.
Wait, accept
Right?
what? Say it again.
The explanation of a sunset and sunrise in a flat Earth, so-called flat Earth, which is not flat because we all know it's bumpy and it has mountains and air kinds of ups and downs.
Okay. What's the difference between what you learned in school versus what you learned here on flat Earth?
Well, in school, you only teach you the heliocentric model. They don't teach you anything else.
No, I remember learning about.
I didn't
remember
learn
learning about
anything else in school
all of them.
besides
Or not
the
all of them,
heliocentric model.
Well, you do know what the heliocentric model is, right?
I had Bill Nye teaching me that all kinds of BS.
Well, again, Bill Nye, Neil deGrasse Tyson, they're not talking to you
Let's not
in the
say
science.
BS, but what he believes is the truth.
I think that they know exactly what they're talking about. Problem is they're taking a professor's, or actually, a scientist's notes and jargon, and he's making it so that we can have a bit of a clue of what they're talking about. It's so anything you hear from Bill Nye or Neil deGrasse Tyson, I promise you, they are so watering it down, it's insane.
Is that what you believe, or is that what you know to be true 100%?
Oh, I know that's 100% fact, because I've heard Neil deGrasse Tyson, Bill Nye. Look, I've heard Bill Nye and Neil deGrasse Tyson talk about these things. I've also heard actual scientists talk, and it's different. They're literally taking so the way I kind of explained it is they're taking a novel and giving you a real quick book report.
Yeah.
And this is the way it is. I mean, do you think you'll be able to keep up with them? I wouldn't. What's up, Barney?
Well, I'm just saying.
Hello.
That there's a ton of people who call themselves flat earthers who tend to disagree with the heliocentric model, man.
Pretend?
And I just find it interesting. No, who tend.
Oh, okay.
Not pretend.
Yeah. Tend. Okay.
TAND, my friend.
I hear you.
To disagree with the current model, and they seem to have some interesting points.
In lieu of, what do you mean?
Well, that's what I mean, man.
Well, I mean,
you know exactly what I mean. You're not new to this.
What points do you take in and believe to be true?
Some points that I think are interesting that they make is that the sun is 993 million miles away, and that the Earth doesn't move. It's immovable, and that's exactly what the sensors tell us, right? But hey, can the sensors be wrong? If they can, let me.
But the census, who's the census? Because the census does not say it doesn't move. The majority.
I said sensors like our five senses.
Oh, yeah. Even better. Yeah, don't trust your senses. That's why we have glasses, because people can't trust their eyes. People, there's a lot of things we have in our daily lives that improve our senses, because our senses not the best.
I know what you're saying. Because sometimes I know what you're saying.
They're dulled down because of technology, in my opinion.
Yeah, but honestly, you have to admit that the sun does look much closer, doesn't it?
No.
To me, it does.
Okay, wait. Hang on.
To my senses,
I would say this. From when I look at the sun, if I had no clue where it was distance-wise, I would say the sun looked kind of small. Here's the deal.
Right.
The problem is I know, or I would come to the conclusion that a sun that is, I know I'm not saying you're saying this, or I'm not concreting it to flat Earth, 32 miles away.
Yeah, don't speak for me, please.
Yeah.
Speak for yourself.
We'll say 3,000. I think 3,000 was the last one I heard. It's
because I don't have any fucking idea how to measure the goddamn sun. Excuse my language, but I have no idea. That's what I'm saying.
Well,
I just to me the sun looks close, like a localized light. But I could be fucking wrong.
Well, if you get
I'm man enough to fucking admit it.
Well, if
but
you get
I'm not. The reason why I came on is because I've been kind of thinking I should probably reassess things and see what I can get out of this. That's what I'm trying to do. I'm trying to give both sides a chance. I hate to admit this, but that's the fucking truth. You know?
Yeah. When it comes down to how solar filter, and correct me if I'm wrong, Barney, or anybody here. I didn't mean to single. The way I think it works is, anybody else want to explain it? Because I have an idea, but I don't know how to explain it correctly.
Where are you going, Shawn?
Well, how to explain it?
You going to talk about angular size or what?
Yeah, just the size versus what is lit during the day. I mean, those are things that play parts, right?
Yeah, that's one of the very first problems you run into with a small local sun is why the thing doesn't change angular size from sunrise to sunset. Stays the same size.
Yeah.
How can that be if it's actually close to the surface of the Earth? When I say close, I mean, whatever you think the number is, 3,000 miles, 4,000 miles, whatever. How can that be? We cannot we can't reconcile that discrepancy, and you can't do it, say, in perspective or it takes some near miraculous special pleading to cause the sun not to change angular size. Something we can't measure or can't have never observed.
I'd actually say you can use special pleading if you want to try to make it go away, but then you actually have to make the problem go away. You don't just get to say, "Oh, refraction, done," or get to say, "Oh, perspective, and done," right? You actually need to show the geometrical proof of what you're saying.
Yeah, it doesn't. Here's the thing. Okay, so in B-ball in the chat kind of was just asked the question what I was kind of leading to. The information you're getting, or Flat Earth is getting, it's not based behind any evidence, behind anybody qualified to give that type of opinion, I guess. You don't, for instance, you don't go to somebody and say, "I'm going to sell this car. It's a truck. It has four-wheel drive. Dude, that's a Honda. Don't worry about it. It has four-wheel drive." That's kind of what Flat Earth is doing. I know you see a car, but it's a truck. It doesn't have big tires. It doesn't have four-wheel drive.
You see that sun?
Mm-hmm.
You see the goddamn sun?
Yes, sir.
Yeah.
Can there be another goddamn sun like that?
Yeah, billions.
The stars? That's what I'm saying, man. You guys think that the stars are suns, right?
Yes.
Yeah.
That's the hard part, man. That's why a lot of people don't want to believe this stuff. Because
then what's a star?
I believe that's an argument from incredulity.
What's that?
What's
a star?
Yeah.
It's according to the heliocentric model.
No.
Or to me.
Flat Earth, or to you?
I don't know. To flat Earth, to me. What's a star to me? To me, it looks like a light, a small light. They look like small lights.
I don't think that's enough to say it's not that far.
But
go ahead. Astronomers, scientists that measure it. Anyone who knows how to measure it?
They look because they look like very like stars that are fixed, that are moving on a something that the Bible calls it the firmament, the dome or the firmament, right?
Well, if we're stationary and the stars are stationary, then how come throughout the year?
I think that's why I think that's why a lot of people hang on to the Bible, because the Bible says, the stars are, in Genesis 1, it says the stars, the God of the Bible created the stars in the firmament, and that's what when you look up, that's what it looks like. But NASA and the space agencies and the universities don't teach that.
Yeah, NASA.
Well, NASA doesn't teach anything.
Yeah, they're in it for themselves. Their job is not to prove the planet at all. They don't care.
Really?
Yeah, I don't think they do at all.
They already know what the planet is. They don't need to prove it.
They already know what the planet is.
Yeah, they've had astronauts.
Who's they?
Any space agencies?
Are you talking about the man who landed on the moon? Who allegedly landed on the moon?
I'm just talking about space in general right now.
There are 6 astronauts on the ISS orbiting the planet at the moment.
Oh yeah, okay. Well, that's the thing. That's the thing is that there's.
And
an
I saw
ISS.
it. I saw it last night.
It goes back to the basics that everyone doesn't want to. Those who know the basics don't want to accept, and those who do accept defend it. That's all. It's all that this whole thing is on the internet. To be honest with you.
No. But here's the thing.
Yeah, it's a conversation.
Yeah. But it's that the difference is are you taking in what you're hearing, or are you just here to give your information out? And I'm not saying you, Manny. I'm saying in general. Because what I see happening, and I experienced in my time as a flat earther, is you're either trying to figure it out, or you're trying to make everyone else realize they're wrong, rather than analyzing the topic, the situation, and the evidence, and actually weighing it with your options. For instance, the simplest observation I can think of is the sunset sunrise. It does not depict what you would see on a flat Earth.
No.
You would have to. Then it'd be, what is it? Is it intellectually
Like
dishonest
there's
to say?
B-ball in the chat room was like, man, you buy a freaking telescope. There's a ton of flat earthers with high, powered telescopes or whatever, and they are still flat earthers.
Okay,
so
hang on.
what are you going to prove with a telescope?
Well, you got to understand what you're looking at.
But you need to know what you're looking at. Yeah.
So, Manny,
So don't
do
give me that
you
argument.
subscribe to that
B-ball
thing
for
that
life.
you
There's a
need
ton
to
of
check
flat earthers
everything by
with
yourself?
high-powered telescopes that still don't accept the model.
Manny,
What's that?
do you subscribe to that thing that you have to check everything by yourself and you cannot rely on the community to give you information?
Not necessarily, man. I'm kind of more in like, if I see it, it's more like, I'll believe it sort of thing. And when I look up I've done a ton of sun gazing, like I already fucking mentioned. I know it's not good for you, but that's what I've done. And I'm still not blind. And I see the sun as a localized fucking light, man. So I'm telling you.
I just
Okay,
remembered.
so wait.
Go ahead.
So you look up at the sun, and you.
I'm not promoting sun gazing, by the way. Kids
Yeah.
out there listening.
You look up at the sun, you look up at the moon, you conclude that they're relatively small and relatively close compared to what the consensus is, right?
Like the sun and the moon actually appear to be the fucking same size, man.
They appear to be exactly the same size, more or less exactly the same size.
And especially when there's a super moon. And have you ever looked at the super moon? Like recently, there was a super moon this year, and like in February of this year.
Wait.
It was beautiful, man. It looked exactly like the sun.
Manny.
Looked like the opposite of the sun.
Manny. So when you come to that conclusion and you see that it doesn't align with the consensus, are you curious enough to try to figure out which one is correct?
Yeah.
Or do you just go, no, I conclude this and it's done?
Well, not really. No. Not really.
Sure.
You don't care to verify your conclusion?
I'm not close-minded, man. But what I'm saying is a lot of the fucking heliocentric explanation sounds really fucking what's the word I'm looking? Pseudo. They call it pseudo, fake.
So heliocentrism has been thrown away
like,
over
for example,
a century ago.
I'll ask you a question, Barney. Are you listening?
Yeah.
How the fuck did this how did we get here? How did everything start?
Wow, that's a.
How many hours of time do you have? I'm fully willing to answer that question, right? It'll just take hours.
Go ahead. Yeah. See, that's the thing. You see what I'm saying?
Wait,
This is why. This
How
is
long?
why.
Wait, how long do you think it should take to explain how we got here?
This is the answer that nobody knows, Sean.
Exactly. I know.
This is why we have this fucking debate.
In a sense.
Yes, because nobody can answer it. No one can answer it. Just be honest.
The
no
beginning
one can
doesn't matter. No one can. No one.
The
beginning does not
say,
matter.
You can say the Earth is 4.5 billion years. Prove it. God damn it, prove it.
They didn't say it was 4.5. That's a good guesstimate.
4.5 billion years.
Yeah, it's a good guesstimate. You don't have to prove it.
Now, creationists will say it's much less than that.
Prove it.
Prove it. That's what I'm saying. and we'll go and like Barney said, it takes hours or days or even months or years.
Yes,
in the explaining value of it.
But
to
try to prove
it. That is because there is a huge body of evidence which is all mutually corroborating. It is not that there was one event where somebody said, "Oh, I have discovered this."
I gotta admit
all the science.
I gotta admit that the heliocentric model sounds a lot more fun than the other models. But
flat Earth, because
you
didn't make it up.
Many, just one clarification.
It sounds more fun.
Manny,
but that's exactly what I think is going. Wait, let me just tell you what I think is happening is somebody created this fun model to kind of take people away from the truth. That's just what I think.
What truth would it take away from?
I can be wrong.
What truth would it take away from?
That's just what I think.
What truth would it take away from?
A lot of truths. Basically, you know the drill.
There are reasons for it, but we
hiding extra lands, hiding extra phenomena, like what's really happening.
You can't hide phenomena; so we'd see them.
Well, like the aurora borealis is one explanation, and like we see the aurora borealis, right?
Yeah, we know exactly why it happens.
They're not. You know exactly why it happens.
Yeah, and we can. They've also made them artificial ones.
But the flat Earth doesn't say that. Flat Earth explains it differently.
No, you don't explain it. No, you don't explain it. You just say it's not the way it's done. That's the difference. I haven't heard
it.
To be honest with you, though, you haven't gone there, man. We all haven't gone there.
But no. There are people that live there. And Barney asked you a question a little while ago. Hang on. Manny. No, Barney asked you a question earlier that was really important.
Wait. Answer this. Have you gone to the exact center of Earth?
Are you serious?
Yes. God damn it, I am. Yes.
That's not a serious question. Of course we have.
The exact center.
Hey, Manny, did you at
That's not a serious question, Manny.
Manny, when you're playing a game of hockey, do you ice the rink as well? While you're playing, do you take your gear off, go ice the rink, and then get your gear back on and continue playing?
Oh yeah, shit.
No, you don't. I know hockey too. So the same way that hockey rink has people working there to ice it. People there to coach you guys or help you with your.
Let's be honest, guys.
To make your gear. You needed other people. Why don't you understand that that's the same way for other things?
I think what I think is the whole flat versus globe. It's like Democrat versus Republican.
Okay,
it's a paradigm that was built
but the difference between
somebody.
No, it's not because listen, the Democrats and Republicans.
But I could be wrong.
Are debating over realistic things. President.
I think he's onto something. Like like it's all fake. Like this whole flat Earth shit. It's all just fake and persona, and it's just.
It is. And the worst part is Flat Earth believes that the government. This is like some kind of government psyop or blah blah blah, and they don't realize that Flat Earth is its own psyop.
But there's arguments that can also
not.
go. There's arguments that people can sit here and argue all day and say that the heliocentric model is the biggest psyop that the government has ever played out on us.
Evidence.
And the American government had the foresight to do it in 600 BC with Pythagoras.
How did that happen?
Develop it over
you
2.5.
can all these fucking Greek names that you have you don't know if this is true or not.
Breathe, man. Breathe,
all
man.
These Greek
Breathe.
names from like 3,000 years.
Breathe.
I'm
I came from Spurs for this.
I'm breathing for sure.
Okay, good. Want to make sure.
So you're saying
I'm telling you guys because you guys sit here hours and hours and hours and hours and hours just fucking defending something and you have no proof.
No. You're saying that. What are you saying? NASA made up Eratosthenes? Are you?
I'm not
you
saying
can't-
NASA
you can't-
exactly.
you can't-
I don't know
you can't-
who. Someone did.
You can't seriously tell me I can't go back to the
Made up
16th
Eratosthenes.
century and find textbooks with references to Eratosthenes. Really? Come on.
Wait. How come they could fake this, the heliocentric model, but they couldn't have faked flat
No,
Earth?
but
And you're
wait.
sure of it.
But I'm trying to like be fair to both sides because right
Okay.
now I'm kind of
No,
in
you're
the
cool,
middle.
You're cool.
So what I'm saying is, can't somebody just make up like the Aristophanes story and all the rest of the stories?
No,
it be possible?
they cannot make it up.
All the
Come on,
observations.
now, you
Of course
know
they can.
Come on,
Look
you
at
know
Pete
they
No,
Jennings.
they
Don't,
can't.
don't
Come
be,
on,
don't
Blue.
be,
Come on.
don't be in it.
I'm gonna fix it.
Don't
No,
like
if you
that,
don't
man.
accept that.
No, time out.
can't be-
You guys
if-
are no, Manny.
If nobody had, hey, look, if nobody had ever heard of the guy until 1950, yeah, you'd have a point. We've been talking about, people have been writing about Eratosthenes for the last 2,000 fucking years.
So you believe the Aristophanes story, then, Big Blue? I take it 100%. It has never been tampered with.
Manny,
I'm having a hard
Big Blue?
time hearing you.
what is your evidence that is happening?
Babe, you're having a fucking hard
No.
time hearing me. Well, clean your goddamn ears.
No,
Big Blue.
because you have a back. Hey, Manny, calm
Hey,
down.
fuck you, asshole.
Yeah, Manny, calm
you.
down, dude. I don't know what the hell you're
Don't
dealing
come
with
in here
now.
and yell like that, asshole.
I'm being honest. You
No,
believe
you're
in
not, Manny.
Aristophanes?
You're being an asshole. You have a lot of background
Come
sound
on.
right now. That's the issue.
Come on.
So
You hear me?
until you're able to be in a quiet spot, mute yourself, and do not ever in your life talk to anybody on this panel like that. No one has
fuck off,
no one has
off.
disrespected you
Fuck
at all,
off,
Manny.
you guys.
So what reason have you decided to become an asshole on here?
I'm not being an asshole.
Yeah, you're being a fucking asshole.
I'm asking you guys if you believe the
No,
Aristophanes
you
story.
just got done snapping that blue for no fucking reason.
I'm not snapping on. I'm
You
trying
just
to get my point
did.
across. I'm saying, do you believe the Aristophanes stories 100%?
No.
You said yes.
No, you
And that's
listen,
it.
Manny. Stop.
Prove it.
Right now, you are out of your fucking mind. You just got done
I'm being
disrespecting
honest.
somebody, and you're acting like you didn't. So
I'm being
apologize
honest.
to Blue or get the fuck off my panel. That's your choice.
I gotta go, man. I'll see you
Peace.
guys later.
Fuck, man.
It's all about nice.
I don't know what the hell his deal is, because he used to be fucking cool. He used to be calm. All of a sudden, he thinks he's some kind of big shot flat earther. He's a fucking asshole.
Oh,
Jesus Christ.
Well, that was
I guess he accomplished his goal.
Yeah.
Yeah.
Fucking show that he has no clue what the fuck he's talking about.
He never has.
Sorry about that, Blue.
no problem, Sean.
Just a little point of pedantry. Heliocentric system has been overthrown over a century ago. Can we stop pretending that it's a debate between geocentric and heliocentric?
Yeah, no. Well, I don't think he knows about the other one, the geocentric. I don't think he knows that because he would have said it.
Yeah, I did earlier claim the standard model of the universe.
The standard cosmological, the current model we're operating under is called general relativity, and it absolutely defeats heliocentrism as a possible answer. The sun is not the center of the universe. It is not the center of our solar system.
Yeah, it wouldn't work too well, would it?
It's not. Right? Even it is orbiting the pericenter of the solar system.
That is insane.
How Barney, as you seem to know this, as you seem to know these things, how close is the barycenter of the solar system to the sun?
I don't know it by heart, but let me Google that for you.
Because I know that the barycenter of the Earth Moon is inside the surface of the Earth.
Yeah, the Earth Moon I know as well. It's 4,000 kilometers away from the center of the Earth, but it's still beneath. Now, the barycenter of the Sun and Jupiter is outside of Sun, just outside its surface.
Pissed me off. I was in a good mood today too.
55,000 kilometers from the center of the Sun, and the Sun radius is... Oh, no, it's inside the sun, according to this. To calculate the actual motion of the sun, only the motions of the 4 giant planets need to be considered. The contributions, if the 4 planets were on a straight line on the same side of the sun, the combined center of mass would lie about 1.2 solar radii over above the sun's surface. So when there's an alignment of all the big planets, then the barycenter is outside the sun. Does that answer your question?
That answers my question very well, thank you. I suppose I could have Googled it myself, but...
I know, fair enough.
I just thought you... from the knowledge you seem to have, I just thought it might be something you had tucked in your head.
I've probably looked at it at some point, but it's not a factor that stuck around. Like I don't remember all the exact numbers at all times, and I do try to point out when I'm pulling numbers out of my ass, but they're in the ballpark, right? I know the general mechanics, I know the formula, I can calculate where it is if I really need to.
That's like he was getting very cross because I only knew the radius of the Earth in kilometers, not miles.
How dare you?
I wonder why he didn't know how to convert kilometers to miles.
And well, he was, but he was saying, "Oh, it's 4,000 miles." I was like,
well, then why can't he convert miles to kilometers?
Okay, but I don't know that. Let me just
Well,
do the calculation
While on the subject of radiuses, you know, the radius of the sun times 108. Sorry, the radius of the sun times 108 is the distance from the sun to the Earth, and the diameter of the diameter of the moon times 108 is the distance from the moon to the Earth.
Oh.
A little fun fact.
Yeah.
A little fun fact.
There are plenty of things, especially in astronomy, which will kind of break your intuitions. The one I really love is the example of I've probably said this one before on the panel. Like, if you set into a car that can drive 100 kilometers per hour in any direction, let's say 60 miles per hour in any direction, and drove it straight up, it would take you about an hour or an hour and a half to get to space, right? And it would take you about 4 hours to get to the ISS. How long would you guesstimate that it would take you to get to the moon? Right? Off the top of your head, just first guess.
A few days, few weeks,
a month.
5.5 months.
Okay.
Yeah, I'm going to say it'll be 24,000 hours, won't it?
Yeah.
Roughly.
Yeah. Right. So the moon is comparatively huge and very far away. Now, in regards to his questions of, well, I look at it and I see it as close and local. Well, you don't. You see a shining object that you cannot estimate by parallax by eye. The distance between your eyes is not enough that your brain can kind of evaluate that distance. Your depth perception has nothing to say about it. So it's it looks about as distant as the farthest things where your depth perception works, which is closer than the horizon, but you'll add a couple of some things when you see it close to the horizon because you can see it going behind and stuff like that. However, there are ways and methods of measuring the proper distance, which aren't really that hard, right? If you take two geometrical ways of measuring, if you measure the angle from one end to the other, as somebody pointed out, and follow it across the sky, you can measure how much it changes as it moves closer and away from you in your apparent vision. And then you can see that it doesn't change all that much and see the distance from there. You can measure the angle to the same point on the moon from 2 different points on Earth. Those 2 triangles will intersect, and you will get one unique answer for the distance of the moon. And then you can verify it further by bouncing radio waves off of it, by bouncing light off of it, by comparing the information with other people on Earth about where the moon is currently on their skies, and all of those different ways of measuring all agree on the same distance and size of the moon. Now, for the sun, it's slightly more difficult because it is far enough away that even that parallax doesn't work. That you just cannot do it that well. You can try to measure it by parallax. You can try to measure it from literally 2 opposite sides of the Earth, but that would take a lot of assumptions that flat earthers wouldn't accept, such as the curvature of the Earth and the radius of the Earth and stuff like that.
You get wild errors when you try that too.
And you'll get an uncertainty, right? You'll be able to say it's between this and this, but it's definitely not 2 meters away from me, nor is it 2,000 meters away from me, nor is it 2,000 kilometers away from me. It's more than something, right? Even the ancient Greeks were able to calculate that. Right?
Yeah, even the 3rd decimal place of the angle, when you start talking about trying to use that method to measure the sun, gives you millions and millions of miles of error.
Yeah, but you can use the fact that we can see that the moon is a sphere, and we can see that Venus is a sphere, and with the telescope you can see the phases of Venus the same way that we can see the phases of the moon. So you can see when it's directly at half Venus, sorry, when it's neither waning nor what's the other one? Waxing, right?
You're talking about maximum
and
elongation of the orbit.
When you see that, you know that the Venus is at 90 degrees.
Yeah, maximum elongation of the orbit.
Exactly, right? And from that, you can then again triangulate. You have the right angle at the sun from you to Venus, and you can see how far Venus is away from the sun, and you can actually get a very, very good measurement of the distance of the sun, which will be consistent with other measurements that you care to take. This is really not that hard. The issue that he's having is that one thing is I can tell you how you can prove these things scientifically, how you can do the measurements and get the right numbers, which will coincide with another measurement of a different kind, and another measurement of a different kind, and another measurement of a different kind. I can do that. How do we know this? How did we get to the point where we are now, and why are we using these terms? Is literally the entire history of philosophy, logic, mathematics, and science. And to tell you that, I cannot give you an answer in one sentence. I can tell it to you over several days of talking. And I'm willing to do that. Like if we're gonna have a prolonged show where we'll just go through from the ancient times to now, discovering all of these things, maths, logic, philosophy, and science, to see how we get to these conclusions that we have now. We can do that, but no, I cannot give that as an answer to a one-line question in a hangout where I'm one of 10 panelists. I think that's very reasonable. Sorry, bit of a rant. I was kind of surprised by his reaction.
I have a question.
Go ahead.
The 80, the 80 or 75% dark energy or dark matter, no, dark energy, and 20% or whatever dark matter, 5%. When they describe the mass, are they describing the area it takes up or the mass?
The mass.
Mass.
The mass. The
We're
literal.
talking about the mass specifically.
How can you?
Or
Yeah,
something,
I saw your yesterday.
or something that
hangout.
behaves like mass.
See, that's how I'm confused because I don't understand how they would measure the mass of something they can't see. I mean, I get the area, but not the actual mass.
No, they're inferring how much mass would be required to match the observations that we're making.
But then wouldn't that? See, I'm confused.
Technically, I mean, if the galaxies should be flying apart.
Yes.
There should not be enough mass there to hold them together.
Yeah. Meaning that there should be more mass to have the gravitational reaction that we're observing.
Yeah.
Okay.
Okay. So wait. Let's go through it one baby step at a time. We can tell how fast things are moving away from us or closer to us using the Doppler shift in light, right?
Yeah.
If something's moving away from us, it's the spectra that its atoms emit, which are known spectra, get redshifted.
Yeah.
All the lines that identify the elements get moved to one side. And if it's moving towards us, it moves to the other side.
Yeah.
How much it gets moved depends on how fast it's moving away or towards us, right?
Yeah.
So we can relatively accurately measure how fast things are moving in the line directly from us, right? Away or towards.
Radial velocity.
So what Vera Rubin did, I think it's Vera Rubin.
Yeah, that's who it was. That's
So
exactly who it was.
Yeah, what Vera Rubin did was she picked galaxies and measured the redshift on one end of the galaxy and on the center and on the other end for a galaxy which is tilted, or on Andromeda, which is tilted towards us, right? And measured what the speeds are in the whole spectrum of the galaxy. So how fast things are moving towards and away from us in that galaxy.
Now,
And she found that if she calculated the amount of matter by taking the solar system as a model and taking the mass of the sun and kind of taking how many approximately stars there are in the galaxy and what type they are and how heavy they are and how heavy their solar system should be and how much gas she can see, and adding it all up together, that the whole thing should be moving slower, right? That the orbital velocity should be slower according to GMM over R squared formula, right? And that the things on the edges were moving disproportionately fast, as though the whole galaxy had a lot more mass.
yeah.
So there are two possible solutions to that problem. One solution is modified theory of gravity, that gravity does not behave constantly the way we see it behave, that on very, very large scales, on galactic and intergalactic scales, gravity behaves differently. And the other is that there is some mass there, and you from those motions that even Vera Rubin directly took, and that were later on supplanted with more and more and more and more data for half a century, right? That we quite finely know. You can calculate how much extra mass would have to be in that galaxy and around that galaxy to get that motion. And
well, here's the thing.
So, in the beginning, you have two options, and those two options are both valid, and you know nothing more. And the name for both of those options is dark matter. It's the identifier that is used to identify the fact that things are moving. Now, modified gravity theories would say that as long as there are stars, as long as there is rocks and planets and asteroids and gas, you don't get this linear shape that's described by Newton's formula or Einstein's formula. It kind of diverges at some point and starts behaving differently, but it would do so for all matter, right? It would do so regardless of the new formula would have to follow for all visible matter. And that would imply that all galaxies have that curve the same proportional to their visible mass.
But
that has been disproven.
Yeah, I was gonna say we know there are galaxies that stars are flinging the fuck off of.
We know that there are galaxies which exhibit this behavior more or less. That is to say, in the loose term of dark matter, we know that there are galaxies that have a variable amount of dark matter which is disproportionate to the visible matter, to the detectable matter.
Yeah.
That and the case that what's his name?
Annie?
Who was here yesterday?
Rumpus.
That Rumpus was trying to scream on top of all of you was the Bullet Nebula. The Bullet Nebula is a collision of two galaxies where the stars, the gas, and dark matter, like two galaxies collided, and all of those things collide in different ways. And some pass each other by, and others just collide and collapse, and we can see them by infrared imaging. We know where the visible mass is, and by gravitational lensing, we see where most of the mass is, where the gravity of those objects is, and they're not the same place. When they collided, most of the mass stayed between them. The gas and the clouds that collided stayed in between the galaxies that passed each other by. But dark matter just went through without touching anything. And there's two blobs of dark matter outside the galaxies that have collided, right? Yeah. So at that point, modified theories of gravity are fucked. And I know that because I've spent almost 3 years trying to develop one of those, like my own version of a modified theory of gravity, which was repulsive gravity, and I'm not. And when I found out about Bullet Nebula, it was just a full stop. It's dead. My theory is dead. There is an observation which contradicts it directly. The measurement of galaxies having different amounts of dark matter, different amounts of the effect of dark matter, negates my theory completely, negates all modified theories of gravity directly. So you had two options, now you have one option. And that option is dark matter, as some kind of substance which exerts gravitational force, which creates the same distortion in space-time, which acts as though it has mass and only mass. No electromagnetic interactivity, nothing except for mass. That's what Rumpus was trying to say yesterday.
He yells too much.
We know that dark matter exists. We know where it is and how much of it there is. There are a lot of things we don't know about it. We don't know what it is. We don't know what type of particle it is, if it even is a particle. Some of the things that we know, we kind of know, right? We can run Illustrious, which is a space simulator that's been the biggest computational simulation of the universe, which requires a specific amount of dark matter per light matter to produce the same shapes and forms that we see, such as voids and galaxies and stuff like that. So some of those things are still kind of speculative and we're not exactly sure. Some of the things we really don't know, but we do know some of those things. We know how much light is diffracted. We know how much the galaxy's rotation is sped up. We know which way things are moving and how things are attracted. And based on that, we can calculate how much more mass we need to add to the universe that we see, and where we need to add it to know how much of dark matter there is. So we know that dark matter exists, and we know how much of it there is. I'm just putting up a defense of Rumpus yesterday because he really didn't defend himself well.
Thank you. And for anybody who does give information out, that's how you do it, compared, and you can see that the information is definitely actually taken in now, and I understand it.
Hey, Barney.
Yeah.
Are you up for doing a little bit of voice acting for me in the future, for reading a few lines in the script? Because
Sure.
yeah, I'll be honest, a science guy I've got an idea for, a little podcast I've got an idea of doing. I'll speak to you in a few weeks about it when I've got some more writing done up.
No problem.
Nice one, dude. Appreciate that.
You have me on probably on on Discord in Shawn G's channel, right?
Yeah, are you under the same name?
Yeah,
I have the same name everywhere.
Yeah, his link's down in my description as well.
Sweet. Thank you. Appreciate that, dude. It'll be fun, man. It'll be fun. I'll talk to you more about it.
I had a question. So I definitely understand now. Thank you. I do appreciate that. Here's the issue, though. I didn't ask. Could dark matter be gravitons?
No.
Why?
It's completely because of what is defined as a graviton.
Okay.
Right? So a graviton is a speculated quantum boson for the force of gravity in quantum explanations of gravity. Right? And that's particle physics. So it depends on which interpretation you take and which kind of school of physical philosophy you subscribe to. But the simplest way to put it is there are no particles in particle physics. All particles are just excitations of their relative fields.
I've been hearing that a lot lately. Why?
Why what?
So I heard it was like I forget which theory it is, but they don't look at it with any, like, particles don't matter, like they don't exist. And I've been hearing that a lot. And when I've been like watching videos to research, or I was reading I think it was, what was it? It was like science, one of those, Science America or something like that. And they keep talking about it as if in certain theories you don't need particles, but aren't particles how we describe or break down something?
Exactly. They are how we describe something. That does not necessarily mean that they are real physical objects. They're not billiard balls. Right? And we've known this for quite well. So that's the part where it falls under interpretations. And interpretations, especially in quantum physics, are a whole can of worms and a whole special system. But it does harken back to what we were talking to the guy before, whatever his name was, Pinocchio.
That was funny. That's a funny name. Sorry.
There is a big difference between knowing something, knowing everything, and knowing nothing. In quantum physics, for a lot of things, we know some things. Some things we actually do know. We know the probability of a particle appearing here. We can calculate it and predict it accurately. And when we do that experiment, we, meaning the scientific community, but I'm not fully justified in including myself, but flashback from a different conversation.
I call those brain farts.
Yeah, brain fart. So there are things we know. Those things can be explained by telling several different kinds of stories about the universe. Those stories we cannot confirm. We have not been able to confirm them. It's in one of the lectures of Feynman that you've played already, he actually talks about this. If there are two explanations which are completely identical in all predictions, in all consequences, then science cannot distinguish them further. Right?
Yep.
It does bear on your thinking process. It does bear on what you can conclude from those. But the thing that the scientific community did was, yeah, sure, you can use whichever one you want personally. You may think one more likely than the other, but until you can prove it, until you can kind of demonstrate, exclude some other for some reason and include your explanation and interpretation as necessary and only, we just don't care, right? We care about the things that we do know, the predictions that we can make. So if your consideration of this interpretation leads you to some conclusion, then we can test that conclusion and add it to the knowledge base, right? Good for you. It's an awesome tool, but it doesn't confirm your explanation, your interpretation of things, until you can exclude others or confirm your own. The reason why I went on this tangent, most of those, including that core method of using only what we know, which is called the Copenhagen interpretation, or has a lovely nickname of shut up and calculate, right? Don't worry about what it is. It's just a bunch of numbers. And if you put those numbers in, we can find correlations between those numbers and find regularities and then predict other numbers. And when we make measurements of those other numbers, we can get an alignment, so we can use it to do practical work. And that's the Copenhagen interpretation. It's literally just shut up and calculate. Doesn't matter what it is. It doesn't matter if it's a particle. It doesn't matter if it exists, right? It matters that we can predict things, and then we can use those things to do useful stuff. And we can use those things, whichever interpretation you've used, to further the cycle along and find out more things and predict better and kind of progress without kind of having more of an understanding, without eliminating interpretations, because otherwise we'd be completely stuck. Now, most interpretations, all interpretations, the thing that we do know in quantum physics is that there is either a violation of realism or a violation of locality. And those are very technical terms, and they bring up a lot of confusion when mentioned in these circles, but kind of necessary for what we're talking about now. Non-realism in physics, in quantum physics, means that those particles aren't there and they do not have the properties that we ascribe to them. Charge has no real meaning. Mass has no real meaning. Energy has no real meaning. Those things are just numbers that are connected or indicative of some regularity. If you indicate those numbers, then those numbers amongst themselves behave in predictable patterns such that you can then deduce, literally deduce, without any chance of being wrong, what some other numbers should be. And that gives you the predictability, right? The other explanation, there is the Bohmian interpretation, which kind of calls on quantum waves and says that the world is real, and a lot of people intuitively, when they hear about it and when they read about Bohmian mechanics, kind of intuitively say, well, there, everything's been solved. It's so intuitive. The problem with that is it gives you realism and it demolishes locality. Locality meaning that there is a somewhere, meaning that this information, like this ladder is black, right?
Mm-hmm.
The blackness of this ladder is a property, it's a color. The blackness of this ladder is in the ladder itself, obviously, right? Well, that's locality. The property is in the object. The object is real, is realism, it exists. It has a property, which is color, and in this case, red. That's realism. And the color is in the object, is locality. Bohmian mechanics violates locality. It says that the properties of an object are somewhere else, literally everywhere else. That you can have a hydrogen atom in the Andromeda galaxy or somewhere on the other side of the universe, shift from here to there, and now suddenly your experiment in your laboratory will read a different reading. Okay? That the property, that the black property of this ladder is actually in this can of juice, this can of pop. And in actuality, in every can of pop and in every hair on my face, and the blackness of this ladder.
I'm confused.
Bohmian mechanics has a further problem. It cannot be relativized. It's
Okay.
an absolute system. It cannot be made relativistic. All attempts to do so have failed. So it doesn't have any chance of producing the grand unified theory. It explains some things as well as other interpretations, but not all of them.
And you're talking about the theory of everything.
Everything that we're talking about is the search for the general theory,
Okay.
the theory of everything.
Okay, yeah. I want to make sure.
Now, when we talked about string theory, right? It's one of those things. It'll give you an explanation. It's really awesome because its explanations are directly connected to its mathematics. So you get the explanation from the mathematics, and it'll tell you why this ladder is here and why this ladder is black. The problem that I've tried to indicate several times to you is if you ask it why this ladder is green, it'll tell you why this ladder is green. Right? But this ladder is not green. So it'll give you the answers to all the questions that you ask, even, right? If you, I've given this example before. If you ask it why an electron is 2 meters wide and red, it'll give you the answer of why the electron, but the electron is not 2 meters wide and red. Right? So it's not that it doesn't explain all of reality. It's that it's not constrained. It doesn't stop at explaining all of reality. It then explains all of non-reality as well. Right?
Mm-hmm.
And then you can no longer distinguish. You cannot make predictions, right? If it can tell me why this ladder is black, but it can tell me why it's green and why it's blue, and even though it's black, then I cannot do this and ask it, what color is the ladder?
Yeah.
Because it will tell me it's all colors.
Yeah.
Right?
Yep.
And that's why string theory doesn't. That's why it's not. It's a mathematical model. It's a philosophical construct. It's not a scientific contemporary theory at the moment.
Okay.
It's promising a lot because it can answer how gravity works and how the standard model works and what all the particles are and how they work. It does all of these things exceedingly well, so it's very promising. But instead of getting more explanation from it, the problem is how to constrain it, how to force it to give you only the answers that apply to our universe and our reality.
Okay, I see what you're saying now. One more question.
Go ahead.
So I was very confused by the lady I was talking about earlier. She was explaining gravitational influencing, I guess. But she was explaining that not only are we expanding, but it's like we're this like just dead in the middle, I guess, or somewhere, anywhere, I don't even know where. It's the universe itself is actually expanding from the inside, from the middle, or it's hard to explain. But it was under the reference of if the universe is traveling at the speed of light, or no faster than the speed of light in its expansion, at some point it would expand, or in ever increasing, it would expand so fast that it would, I guess, tear tear the universe, or the universe, I guess is how you would have to say it. And I don't get it. And maybe I explained it completely wrong, and now you don't have anything idea what I'm talking about, but I wanted to ask.
Okay. Can you try explaining it again?
I could definitely try.
Okay.
Okay, so universe expanding and increasing its speed in its expansion.
Okay. Yes.
Physics says the universe that is expanding cannot surpass the speed of light.
Bullshit.
Okay. Now, once it does, it will essentially, or I'm sorry, while it's doing this, so I guess in wherever there's less matter, I don't know where it would happen, but the universe, inside the universe, is actually expanding as well, almost as if.
Shawn,
Yeah.
Shawn, I think by the time that hypothetical conclusion would get to its point, I think all matter and light and everything in the universe would have dissipated by that point.
Thank you. Perfect. Oh my God. Thank you so damn much, because I was missing a big part. Because of the expansion, all the stars and everything that we see becomes so far away, there becomes actually a huge nothing void in between us. That's when it would happen. Thank you so much, Freeman.
There's two possible conclusions from the expanding universe of how the universe will end. One possibility is it'll just expand forever, and things will slowly decay and fall apart, and everything that is connected in some way to a force field will eventually, through a chain of decay into a photon. But as the universe is expanding, the void will become so great that those photons will kind of become sparser and sparser and sparser and sparser, and the universe will generally cool down until those photons can no longer interact with each other, and that's called the heat death. Now, it was I think it's 2015 Nobel Prize was given for the discovery that the universe is actually accelerating in its rate of expansion, which is the proof required for dark energy. And again, dark energy is a placeholder for what it is. We don't know what it is, but we know it's there because the universe has been confirmed to be increasing in its expansion.
I don't even know what the
accelerating
fuck. I have no clue what dark energy is.
Let's just not go there.
Okay.
So that implies a slightly different end, where it's called the Big Rip, kind of like a pendant to the Big Bang, where
the point
the amount of energy which is causing this expansion per, let's say, cubic meter is always fixed. But what that energy does is it literally rips the space apart, makes it bigger. So it was 1 meter cubed will become 2 meters cubed, but the amount per meter cubed is still constant.
Yeah.
Right? So the whole thing is accelerating and accelerating and accelerating through this self-feeding generation of expanding energy. Right?
So it's like
Now,
the
at
clown.
this
That's
point,
like the clown flag trick where he's constantly pulling it out. The universe would tear and then constantly coming out.
at this point, the amount of energy causing this expansion all over the universe is such that it causes, I don't know, several centimeters over, I don't know how many parsecs, right? The scales are huge, and it's literally the expansion of the universe doesn't affect formations on sub-universal scales. If you look at galaxies, the gravity of a galaxy far, far, far surpasses that expansion. But if that expansion is constantly accelerating and there's more and more and more of it, at some point that expansion will overcome gravity. And then it will overcome the electromagnetic forces. And then it will overcome the nuclear forces. And at that point, everything will be literally ripped apart into electrons by the universe, which is streaming away from everything at superluminal speeds. Now, the speed of limit, the speed of light is a limit within your movement of space, right? Within your movement through space and time.
Your reference point.
However, there is no such limit imposed on space itself. And this expansion kind of proves that space itself is moving and expanding. The very fabric of space is kind of getting stretched out between those things. It will cause that rip of things. And yes, that means that things as close as and the particles of an atom will eventually get ripped apart at superluminal speeds, right? As the space beneath them starts moving in different directions at the same time. That's the big rip. That means that the very thing which matter is will get ripped apart, and again ending in the very similar scenario as the heat death.
Yeah.
Where you will have a photon moving in any given direction at the speed of light, and every other photon in the universe moving whichever way it's moving away from it faster than the speed of light. So not even two photons will ever meet each other again. Not by being improbable, but by being impossible. There will be no space or time for them to meet in.
Yeah, there'll just be no opportunity for entropy to improve. Oh, my food's there.
The hell?
So that's the big rip. And what she was describing, or what you're describing that she was describing, sounds very much like that.
Yeah, that's exactly what it was, and I didn't describe it. You guys did. I gave you a couple pieces, and that was about it. But thank you, I do appreciate that, because it makes more sense now of what I was thinking in my head. I think I was kind of leading to this question with all my questioning. On a realistic idea of this, how much does dark matter affect us? Or will it affect us once we figure it out? Because all these new theories that are coming about now, and explanations for things, and the observations we're making, and the idea that gravity doesn't work as we thought it did out on the edges of our galaxy, does it really affect us here?
Well, it depends on what you mean by affect us. So does it interact with us except gravitationally? No. And that gravitation is kind of like, does it affect the life of Shawn G? Practically? No, not at all.
Okay.
Right?
Yeah.
Sorry about that. The delivery guy rang the doorbell.
No worries. No worries.
Does it affect you? Well, yeah, you wouldn't. If our cosmological models are even vaguely accurate, you wouldn't be able to exist without it. There would be no galaxy formation without it.
I wonder if brainstorming, if like the dark matter keeps that rip from happening.
Not enough of it, And the problem is that the amount of dark energy is not constant, right?
Yeah.
It's constantly growing as there is more space, like literally space-time.
Mm-hmm.
There is more dark energy, which creates more space-time, which then has more energy, which creates more space, right?
Mm-hmm.
So right now, the gravity of ordinary matter is able to withstand that pull. The effect of dark energy is so much weaker than gravity, even though gravity is so much weaker than the other forces, that it's negligible completely on our scales.
It's all about mass.
Right? But eventually, it will not be that there is, I don't know, 60-something% or 80-something% dark energy in the universe. It'll be effectively 100%. Everything else will be negligible. And at that point, dark matter will not be able to, gravity will be irrelevant. Right? As I said, every force will eventually succumb to this expansion,
Mm-hmm.
if it's a linear law of nature.
It's crazy. That's amazing how that works, because I'm just trying to wrap my head around how they did that. But yes, I got a bunch of different questions running through my head now. Because for instance, in the same lecture that I was listening to, she started to go into special relativity, the twin paradox, and the idea that, and this is still into the constructs of the speed of light. So if two objects are going away from each other at the speed of light, are there reference points shouldn't be able to see more than the speed of light, right? Or I'm confused again, but I'm just trying to understand what I was hearing, and it doesn't make sense. So, or am I going too far? That's probably the even better question. Am I jumping too far ahead into what I'm looking into? Probably.
Can you simplify the question? Can you restate it again, please?
Okay. So we are supposedly held tied. The speed of light, or we're basically told that the speed of light is we can't go any faster. That's I think. But when the lady was explaining the twin paradox, which is one at a stationary reference point and the other one going into space, blah blah blah. But if they're both going in different directions at the speed of light, would someone at that reference point see faster than the speed of light though? Or no? Could you be looking at both of them? Okay.
So that's the whole point of Lorentzian transformations, right?
What you say, Lauren? What?
Lorentzian transformations. So general relativity explains the universe through Minkowski spacetime. Minkowski is Einstein's teacher and tutor and mentor. And right before them, and at the same time with them, there was a physicist called Lorentz, who had his own explanation of space and time for the purposes of electromagnetic forces.
Oh, yeah.
Who had come up with a way of transforming things to maintain the speed of light for all observers due to Maxwell's equations. Maxwell has come up with a set of I think it's 4 equations which kind of cover all of electromagnetism and produce the speed of light as a physical law, not as a measurement, not as a factoid, but as a necessary physical law. If electromagnetics follow his equations, then the speed of light is that, right? So Lorentz was kind of trying to fix that. Einstein finally fixed it by using Minkowski spacetime, Lorentz transformations, and Maxwell's fixed speed of light. But Lorentz transformations, what's a transformation, right? Transformations are translations, moving one thing to another place. Rotations, rotating it, right? scaling something, those are all transformations. Some of those are real and coincide with space-time, others don't. What Einstein kind of calculated is that Lorentz transformations apply to things moving through space-time as he described it. And under Lorentz transformations, if you have one thing going at half the speed of light that way from you, you're the observer. You set one thing going that way at half the speed of light and the other going that way at the speed of light. And then you move to the perspective of this thing moving away from you, right? And watch as it's moving away. Now that's the new origin. So it sees you moving away at half the speed of light, but that thing that's moving away from you at half the speed of light is now moving at 0.75, right? At the at the 3/4 of the speed of light. If you go at 0.999999 of the speed of light in opposite directions from each other's point of reference, you will still not be moving at the speed of light. Nothing moves at the speed of light through space-time, right?
I hear.
At some point, I am going to have to sit down with you and show you what Lorentz transformations are and how they work and how from them you get the what is it? Contraction of space, dilation of time, and violation of concurrence, right? Of simultaneity, which are all very non-intuitive things and all very hard and all very clear from the math. And I believe that I can demonstrate the math without doing actual math, without numbers, right? Just using graphs and when you figure that out, you will basically be able to understand special relativity. And from then on, it's just one step further to general relativity. But yeah, there is no way for something to be moving away from another thing, to be moving in another thing's frame of reference at the speed of light or greater without the space itself expanding underneath it to
information
that motion.
travels faster than the speed of light.
No, it doesn't. There is no process with which you can send information faster than the speed of light. Even if you take entanglement, which is an instantaneous correlation between events, you still have to get information subliminally from one point to the other to transfer, to compare those results to get any meaningful transfer of information.
Even Einstein said information travels at the speed of light. That's why he called spooky action at a distance.
You're breaking up very badly, but that's exactly what I'm talking about. It's spooky action at a distance, but it's not information. There is no possible exchange of information in entanglement. It is spooky action at a distance, but you cannot transfer information in it.
Just agree to disagree.
Okay.
Why do you disagree?
Because I've seen other particle physicists and other people say that they would agree with what I'm saying.
What, that it could be used as a form of transferring information?
Well, if you want to get all philosophical about it, yes, it is the transfer of information. I mean,
Yeah,
but like what
is
Barney says is that you can't get that information faster than the speed of light, but it's happening. The transfer of information is actually happening faster than the speed of light, but you're not going to be able to obtain that information.
So that information is non-localized, meaning that half of the information is in one place and half of it is in the other. Now, to get the information, to get, to get a useful message through, right? The collapse is simultaneity violating. You can have the causing effect and then have the consequence before it in the quantum eraser double slit experiment, delayed quantum eraser double slit experiment. You can actually have the consequence precede the cause, right? But to get the information contained within it, you have to wait for the cause to happen, then get that information, compare it to the consequence, and then see that it was always there, right? So the information cannot travel back through time. Information cannot travel faster than the speed of light. Information is dislocated. It's in a state of superposition until you can, by normal speed of light means, get both pieces back together again to get the information which was contained in it. Interpretations vary. We've talked about interpretations a bit earlier, right? That there are many different ways in which it can be explained, but none of them violate this. You can say that those two particles have exchanged information amongst themselves, but that information is still unavailable to the universe until it gets transferred at or below the speed of light. Is everybody still here? Am I cutting out?
No, still here. I was just thinking, trying to remember what I know about spooky action at distance, and for the life of me, it's escaping me. But what I think I might be getting conflating the two, but I think it's similar to entangled particles. For example, say say you're on the moon, and you've got an envelope that's unopened, and I've got an envelope that's unopened, and there's a letter with a thumbs up on it and a letter with a thumbs down on it. If I open up my letter, then I immediately know what the other one is, because it's the opposite to this one that I've just measured and discovered. So I immediately know what the other one is because it's entangled. Is that what, Maxwell? Is that what you're talking about?
So what you have described is called hidden variable theory. And hidden variable theories were conclusively disprovable by Bell experiment. That is impossible. You cannot have both realism and locality of information. Right. The spooky action at a distance, like you can take a left-hand glove and right-hand glove, put them in a box, swap up the boxes so that you don't know which one is which, take them as far apart as you want and open them, and when you see the glove, you will instantly know which one is in the other. That's not what's happening.
Yeah, I was conflating too. Yeah, it's been a while since I looked at stuff like that.
That's a hidden variable, which implies both reality and locality. That has been conclusively disproven. It is impossible that it works that way.
Fair enough. Hairy muff. It's all about mass, mate. It's all about mass.
It's all about mass, and Bell's theorem and Bell's experiment generally fucked up the minds of many people who were researching quantum physics and trying to make it logical and kind of constrain it to classical physics. And nope, sorry. Hey, Rumpus.
Uh-oh.
I think you've just made a mistake there. That is the fundamental EPR paradox. The idea is that you don't know what the state of, say, the spin of an electron is, and then the opening envelope is the equivalent of then finding out. And then at that same time, it all depends when you decide that this happened. If you open up the envelope on the moon that will then cause, and you find what it is in there, then although you didn't know ahead of time, the hidden variable thing is where you know ahead of time in some way. In the EPR paradox described by then the act of opening it, then the value in the other envelope is then fixed.
Yeah.
So that's not the hidden variable theory. He got it correctly. He wasn't describing the hidden variable theory.
No, if you open if the state inside the envelope has been fixed all along.
No, only if it's been fixed all along. But he didn't say that. I don't think he was implying that, was he?
Well,
I wasn't. No, I was.
No, he wasn't. You see, so he was saying that only on the point of opening it is the value fixed, becomes fixed.
Okay, not in that case. Yeah, in that case, I was wrong. I understood it as the gloves example, right? Because if you put two gloves in boxes and take them to distant places, the gloves inside the box are a hidden variable. The one that is left hand is not uncertain. It has always been the one.
Yeah, that's correct. That's the hidden variable theory. He wasn't describing that, I didn't think. And
I was like, I thought it was entangled particles, meaning like if like exactly what I said. You know, if you open that envelope and it's thumbs down, then you immediately know mine's going to be a thumbs up because you've just opened one and measured that variable. You know, so the opposing one, which is
the key difference. The key difference between the hidden variable and is that the state inside the envelope was not merely unknown. There was no state inside it. The state was unreal.
The act of opening the letter was what created
what created the information. What made it go up and down, right?
Yeah, so this is what I was saying. Was that what Maxwell was on about when he was saying light can travel faster than the speed of light? Because it's not really traveled. The knowledge of it is traveled. If it makes sense.
Yes. The information when you open one.
That's the information. That's the theory that information travels faster than the speed of light.
No, it's not, because you don't know. You cannot create the envelope with information in it and then have it being revealed. The point is, it's random. You do not know what the envelope contains, and it could be either of the two cases. You do not know. And
I know, but if you have an envelope on one side of the universe and the one that you're opening, the one that you open here on Earth, now you know what the one on the other side of the universe is. That's information traveling faster than the speed of light.
You wouldn't have known
the information. Right. So the meaningful information would be if you know when the one on the other side of the universe was opened, when was the superposition destroyed, when did it attain a perfect a meaningful bit of information, right? That bit of information is unavailable to you, so you cannot use that to send messages. Therefore, there is no. There is no information.
No. It wouldn't be. It couldn't be.
It's a simple information of knowing that it changed. It's not an encoded message, or a letter, or a text message that you send across space. Simple.
Well, no, you're presuming it's changed.
It's been shown that it
Maxwell,
changes.
you are presuming, because you've got the positive, because you've seen the finger up, you are presuming that the other one has become a finger down. You don't know that yet. If you wanted to find out that's what actually happened, that has to be communicated at the speed of light. You can't confirm that has happened. You're just presuming it from theory by saying, I've got this open envelope, says thumbs up, and therefore, because I know about this theory of entanglement, I'm going to presume that the other one at the end of the universe.
I thought that they provide good evidence that entanglement is pretty accurate.
Yeah, but you can't know that. You can't know that the other envelope is now saying fingers down. You can only know that.
Well, you can say that about anything, Rumpus. You can say that anything that you observe in reality is a presumption. Then
no,
get out of here.
You can't. Oh, Jesus Christ! Oh, you cannot. You can confirm to confirm that the other one. Look, the idea is that when you open up the envelope, we're saying we've got a theory written down on a piece of paper that the other one will be the other way round. And indeed it is, but you can't confirm that without doing a measurement at the speed of light. And also you cannot communicate information in the sense of putting something in the envelope and it being communicated the opposite. You cannot put something in an envelope and the other one at the other side of the universe or on the moon is going to be the opposite. All you can do is, it's just a read function. You can't write anything with this. You can't initiate the information. You can just receive it. And you have to presume that that thing at the other end of the universe or on the moon is the opposite. You don't know that for sure, except by saying, well, my theory says that this is what it will be. But to actually get that information for sure in the sense of receiving that information, that's still going to be done at the speed of light. The idea of communicating information means you have to be able to decide what the information is, and then you have to communicate it to somewhere else. And it's got to arrive in the form that the information's got to arrive as you intended. That's what communicating information is. Just being reading information.
Did I say communicating information? No.
Well, that's
now you're assuming that I'm going to